Hey guys, welcome to a problem set dealing with experiments. So let's start with this problem that I found online. Well, I found the study online and I made a problem out of it. So studies suggest that striped coats of zebras can prevent biting fly attacks. So studies suggest that striped coats of zebras can prevent biting fly attacks. Biting flies are serious livestock pests that cause economic loss. Researchers hypothesize that cows painted with black and white stripes could avoid biting fly attacks and show fewer fly-repelling behaviors. 6 Japanese black cows were randomly assigned to 3 treatments: black and white painted stripes, black painted stripes, and no stripes at all. Fly-repelling behaviors were recorded, which included head throw, ear beat, leg stamp, etc. Photo images of the right side of each cow were taken using a commercial digital camera. Evidence showed that the number of black biting flies on Japanese black cows painted with black and white black stripes were significantly lower than those of the other 2 groups. And I want to know, is this study an experiment? Why is this study an experiment and not an observational study? So, the reason it's an experiment and not an observational study is the researchers imposed the treatments. The 3 treatments to the cows. So the researchers basically inserted themselves in the study and imposed the treatments. Can you generalize the results of the study to all cows? No. Our sample included only Japanese black cows. So we can generalize it to all Japanese black cows. Identify the following, the experimental units. The 6 Japanese black cows. What about the explanatory variable, which is the thing that's being manipulated? The paint, or lack of, on the cows. What about the response variables? The response variables were the fly repelling behaviors and the number of flies on the cows after each observation. All right. If the experiment did include a group of cows with just black stripes painted on their black skin, what might a potential confounding variable be in the study? So you had 3 different groups, 3 different treatments. So I'm gonna do a quick paint of this. So you had the black and white paint. You had the black paint. And then you had no paint. And it's saying, excuse me, I've got allergies. I'm pretty bad right now. It's saying if there was no black paint group and you only had these 2, let's say 3 cows in each, could you conclude that the striped coats, the thing we had at the very beginning here, like the black and white striped coats, was the thing that's repelling the flies? And the answer is no. A potential confounding variable without this third group of the black paint group would be the paint chemicals might be a confounding variable. The flies might be repelled by the chemicals and not the black and white stripes. So that is a basic experiment. Now, a well-designed experiment should include the following. Comparison of at least 2 treatment groups, one of which may be a control group. So did we have that? Yes, there were 3 treatment groups for our experiment. Random assignment allocation of treatments to experimental units. Yes, the treatments were randomly assigned. What about replication? Replication is more than one experimental unit in each group. Yes, there were 2 Japanese black cows in each treatment. And finally, control of potential confounding variables. Yes, one of the treatments was black painted stripes to control for paint chemicals. There you go. So our experiment checks off all 4 components of a well-designed experiment. Here is question 3 from the 2016 FRQ. Alzheimer's disease results in the loss of cognitive ability beyond what is expected with typical aging. A local newspaper published an article with the following headline: Study finds Alzheimer's strong association between smoking and Alzheimer's. The article reported that a study tracked the medical histories of 21,123 men and women for 23 years. The article stated that for those who smoked at least 2 packs of cigarettes a day, the risk of developing Alzheimer's was 2.57 times the risk of those who didn't smoke. Identify the explanatory and response variables in the study. So the explanatory variable is smoking at least 2 packs of cigarettes per day, which, by the way, is 40 cigarettes. The response variable is developing Alzheimer's. Is the study in the article an observational study or an experiment? Explain. Observational study. The researchers didn't impose the treatments. It'd be pretty crazy if they did. Exercise status, regular weekly exercise versus no regular weekly exercise, was mentioned in the article as a possible confounding variable. Explain how exercise status could be the confounding variable in the study. So what we're saying is smoking 2 packs plus per day leads to developing Alzheimer's. And we're saying exercise status could be a possible confounding variable. So how could exercise status be a confounding variable in the study? So we would say assume exercise leads to a lower risk of Alzheimer's. Now, people who exercise more are more health conscious. So exercise status, more health conscious. And less likely to smoke. So what you want to do is you want to tie the confounding variable, which in this case is exercise status, to both the response variable, as in exercise status. Exercise status has an impact on developing Alzheimer's, and on the explanatory variable, which is people who exercise more are likely to smoke less because they care more about their health. So what looks to be smoking leads to developing Alzheimer's, it's actually exercise status that's related to both. That's the thing that's like responsible for the response variable. Okay. Here's question 2 from 2011. People with acrophobia, fear of heights, sometimes enroll in therapy sessions to help them overcome this fear. Typically, 7 or 8 therapy sessions are needed before improvement is noticed. A study was conducted to determine whether the drug D-cycloserine used in combination with fewer therapy sessions. So they're going to use a drug with fewer therapy sessions. Normally, 7 or 8 sessions are needed for improvement. So they want to cut down on the time it takes to improve. Would help people with acrophobia overcome this fear. Each of the 27 people who participated in the study received a pill before each of the 2 therapy sessions. 17 of the 27 people randomly assigned to receive the D-cycloserine pill, and the remaining 10 people received the placebo. So a placebo is a fake drug. After the 2 therapy sessions, none of the 27 people received additional pills or therapy. 3 months after the administration of the pills and the 2 therapy sessions, each of the 27 people were evaluated to see if he or she had improved. Was this study an experiment or an observational study? Provide an explanation to support your answer. So, the study, it was an experiment. The treatments were imposed by the researchers. So the keyword there is treatment, imposed, and researchers. When the data were analyzed, the D-cycloserine group showed statistically significantly more improvement than the placebo group did. Based on the result, would the researchers be justified in concluding that the D-cycloserine pill and 2 therapy sessions were as beneficial as 8 therapy sessions without the pill? Justify your answer. So our experiment looked at, it compared the pill plus 2 therapy sessions with placebo and 2 therapy sessions. So can I conclude that the pill and 2 therapy sessions are as beneficial as 8 therapy sessions? No, the 8 therapy sessions treatment was not part of the experiment. So I can't compare it to one of my treatments. A newspaper article was summarized that summarized the results of the study did not explain how it was determined which people received the decycloserine and which received the placebo. Suppose the researchers allowed the therapist to choose which people received the decycloserine and which received the placebo, and no randomization was used. Explain why such a method of assignment might lead to an incorrect conclusion. So when you're asked a question like that, you want to make up a way that the researchers could group people in a way that is not random. So you could say, suppose that the researchers gave the pill to subjects with most severe cases of acrophobia. Let's see how to spell it. And the placebo to the most mild cases. Then the improvement could be a function of the initial severity of the case and not the pill. Or you could say something like this, and you just have to do one or the other. I'm just going to give both examples. Suppose that the researchers gave all the pill to all of the males and the placebo to all of the females. Also, suppose that males and females react differently to the drug. The experiment would, or I'll say this, the improvement would then be a function of gender and not the drug. So 2 examples, just come up with one way that they could react differently and how that would be problematic. And that would do it. So you just have to do one or the other. You don't have to do both. In fact, pick one and go with it. So that's a general overview of experiments with 2 actual questions, one from 2011 and, excuse me, I'm trying to sneeze, but I can't, and one from 2016.